Hello and welcome to this session of the course Elements of Mechanical Vibration. Now, having discussed many of the fundamentals of the vibration theory, I thought we can now get introduced to some of the practical vibratory systems. So, what we are going to do is record some experimental tests on some simple vibratory equipment, and through that process learn a bit about the practical vibration measurements and the estimation some of the parameters of the vibratory system. So, in the set of experiments that we are going to conduct in this course, we will first get started with a very simple free vibration apparatus, which is a trifilar pendulum, in which the natural frequency of the trifilar pendulum is going to be obtained through a measurement process, and through the use of this trifilar pendulum we will try to get the mass moment of inertia of a mechanical element such as a connecting rod. So, this will be the first experiment that we will conduct. The second experiment will be on a universal vibration apparatus, where a simple oscillatory system which comprises a mass, a dashpot and a spring will be taken up, in which we will record the time displacement plot, and from that we will try to extract the natural frequency as well as the damping ratio. We will see the effect of adding an additional dashpot in the vibratory system and how it enhances the damping and therefore, a reasonably quick decay of the free vibration amplitude. This will be followed by a 2 degree of freedom system, in which we will first start with a double pendulum apparatus, where we shall see how the initial disturbance or initial conditions influence the ensuing vibration response, and by tuning an appropriate initial conditions we can make a 2 degree of freedom system oscillate in either the first or the second mode of vibration. This will be followed by an experiment on the same setup, which will demonstrate in the practical way how an arbitrary initial condition, which does not conform to either of the two mode shapes, will generate a general vibratory response comprising more than one mode of vibration, and in that light we will observe a phenomena called as a beat phenomena. So, this kind of a actual measurement will help us reinforce the learning that we had for a 2 degree of freedom system. This will be followed by a forced vibration response of a 2 degree of freedom system, and so for that purpose we are going to look at a coupled pitching and bouncing apparatus, wherein we will try and excite a pure bounce mode or a pure pitch mode or a coupled pitch and bounce mode, and through a force excitation case on a simple coupled pitching and bouncing apparatus, we will observe the resonance and the way the vibratory system responds to a given excitation function. In addition to this experiment, we will conduct couple of other measurements, and in that light we are going to observe how a typical fitness machine is modeled, like a simple spring mass dashpot system, and for that purpose we will demonstrate the measurement done on this fitness machine, and we will provide you relevant data, so that you can model this practical vibratory system yourself and find out the vibratory response through a numerical simulation. The practically measured vibration data will be then compared with what you obtain from the model, and the comparison will help you understand how a practical vibratory system can be modeled. In addition to that, we will take up a multi degree of freedom system modeling, and for that we have a piezoelectric sensor, a sonar transducer, which is used in naval systems such as torpedoes, and these sonar transducers are nothing but vibratory systems, wherein the piezoelectric discs in the form of a stack is used, compressed between two masses, and then it is externally excited to generate the vibratory response, and that response then translates to sending a signal into water. So, this sonar transducer as a vibratory system, I will explain you how the construction is all about, and then we will carry out actual vibration testing on this sonar transducer to estimate or to measure its natural frequency by a sweep excitation, wherein the excitation at different frequencies are provided to the sensor, and the frequency at which the sensor responds with largest amplitude of vibration will be obviously then inferred as its natural frequency. We will model this transducer and then find out its natural frequency and then compare it with the observed resonance frequency to see how they match with each other. That will give you a confidence how a practical vibratory system can be modeled and the measured data how well it compares to the model. In the introductory lecture, we discussed a music box wherein a series of cantilever beams are excited through initial disturbance, and the response of these cantilever beams in the form of a single tone frequency radiates a melodious sound. And in this particular experiment, we are going to model these individual beams as many number of segments using numerical analysis approach and find out its natural frequency. We will find out the sound which is radiated, and the frequency of that sound is expected to be the natural frequency of these cantilevers, and therefore, we can verify whether the numerical model generates the right natural frequency which can be confirmed from the measured sound data.